Hello and welcome to the Dynamics project. My name is Marwan Mohammed Magdi, matrix number 208650. Today we're going to talk about the kinematics of jet engine. The basics of it is you have five components: the diffuser, the compressor, which sometimes has multiple stages, and the combustion chamber, the turbine, which gives power, and the nozzle where the exhaust gas is ejected. Thrust is produced when the fuel is injected. Sometimes that has negligible effects like some vibration and kinetic energy, but it's usually negligible. And with compressed air in the combustion chamber, thrust can be produced. There's a lot of factors that can affect the thrust, like as shown below: the velocity, the power extraction from the hydraulics, the humidity, the bleed air, and jet engines usually have to accommodate like for certain conditions, and they have to withstand all of these conditions. So moving on, now we have an exercise. As shown below, we have some values. The compressor pressure ratio is 11, it's going to be very important. And the diffuser and the nozzle are isentropic, and the compressor and the turbine has an isentropic efficiency of 85 and 90. And the kinetic energy everywhere is negligible. So we have to determine the velocity of the nozzle exit, or as VE, and the thrust is developed by the engine. So for now we can. So yeah, for now we're gonna do just pressure changes and isentropic compressions, and that's why we're gonna have the piece of R as shown. We have pressure, temperature, velocity, kinetic energy, and enthalpy with the respective units. So now we're just going to plug in our values, and for now we can get the kinetic energy like the 24.2. We already have the equation for the kinetic energy is half v squared, but we have to be very careful because of the conversion factor. It is 1000 meters squared per second squared, and that will be equal to 1 kilojoule per kilogram. So if you didn't do the conversion rate, it's going to be 24,200, but after conversion factor, it's going to be 24.2. Now we know that the enthalpy, it's a function of the temperature, so we can get that, and we already have our value. We also know that the R is a function of temperature, and it can be easily attained. Now moving from state A to state 1, what happens, we go from state A to state 1, is the isotropic S equals to the constant, which is now is the isotropic compression through the diffuser. Okay, now we're gonna do the enthalpy first. So I want to calculate the energy balance equation, which is down below. So H1 equals to HA plus the kinetic energy of state A. And after we get that, it's gonna be down there. And most of the equations is gonna be derived, most of the values is gonna be derived from the functions of others you're gonna see now. And now for the middle part, now we need the piece of R2S, and to get that, we have to multiply it by the compressor pressure ratio, multiplied by piece of R1 will give us the value of 8.553. For now, to get the work compressor isentropic, if you noticed, it is the difference between enthalpy 2S and enthalpy 1 that will give us the minimum work, but we have to account for the 85 efficiency, which will be divided, excuse me, not multiplied, divided 85.85 equals the 295.5. Now we need to get the P2 for pressure 2. We'll just take the pressure 1, 36.9, multiply by the compressor pressure ratio will give us the value of 406. And now for the end part, after the combustion chamber, notice that we've known how to get the P and how to get the enthalpy and how to get the piece of R. So what we want to do now is get the piece of R5 as the last piece, and to get that, we're just going to put it in the formula of P5, we have that, divided by P4 equals a piece of R5, we don't have that, over piece of R4. So after the calculation, it's going to be 31.9 and 0.91 is shown here. After that, we're going to move on to the kinetic energy. To get the kinetic energy of 5, you might ask why, because that will give us the velocity for the exit velocity, excuse me. So to get the kinetic energy 5, which is gonna minus the enthalpy 4 minus 5, and that will give us 485.85. That's the kinetic energy for 5. And to get that, we're gonna put it with the equation over 1 over 2 multiplied by the velocity squared, and that will give us the final velocity, which is 986 meters per second. For the last part, we have to get the thrust, which is the easiest part. Thrust is equal to the mass flow rate, which is given, times velocity exit minus velocity initial. So the mass flow rate, which is 25, is given, and with the velocity exit that we just got, and the 220 velocity initial, it's given, and that will give us 19.43 kilonewtons.